Okay, hello again, welcome back. What I want to look at today is the capacitive calculations in connection to time constant. Now, there is actually two parts to this calculation, but I have not been able to find the first part. So what I've done is simply put the information I have done already on the channel, okay? So please do bear with me. I will try to find the first stage to this, but for some of you I felt that this information could be useful as you go on to do ONC or HNC level work, okay? Especially if you're in the BTEC area of work, okay? Now again, I don't need to read this out to you. You can read this for yourselves, okay? It's quite clear, okay? And all I want to do is let us look at the following example, okay? Now, you'll see here the example for t equals 0 plus. I've given you 3k is in parallel with 4k. Now, keep that in mind because those two lines represent parallel, okay? And I've gone on to draw the diagram. Again, always draw out the diagram, show you're working, okay? It enables your understanding of the work to be done, okay? Now VL equals V in times R2 over R1 plus R2. Now that is a constant formula, okay? Variations of the same formula has been made, or an additional resistor may have to be added or be taken into consideration in regards to this formula, okay? Now we now need to find total resistance of the parallel element, and again remember that the parallel element is 3k and 4k, and I've shown you how to do this using the two resistor method, okay? And the total value here is 1.714 kilo ohms, or 1714 ohms, okay? Now again, back to keeping in mind VL equals V in, putting that into place, and again you'll see R2 is 1714. Now that became R2, okay, over R1. Now again the formula remains consistent. It's just a manipulation of the said formula, okay? Now continuing with the example, okay, here we have VC, that's the voltage across the capacitor, V, T equals infinity. Okay, I'm going to get a little ahead of myself here, okay. And the question here is, how did we get 1.82 volts? And you can see I've applied a solution here for us to see, okay? And again, write out the work. You cannot just look at it on screen. You need to be able to find the process that enables us to reach a solution, and you need to be able to apply that for yourselves, okay? And remember here, all the calculations are connected to the original diagram, okay? and here I've shown you the process again. Here we got 3.94 volts. Now time constant tau okay, and here we have the final part coming up now. Okay, again, check the calculation on your calculator, and make sure that the answers we have here on screen is what you yourself have received on your calculator. Don't ignore it. Okay, and that will be us for now. Thank you. Okay, have a good day, and I hope this information has been useful. Thank you. Bye bye.